Lesson 5 is about evaluating logarithms, and some logs we evaluate with a calculator and some we don't. So in 5.1, we're going to learn about the common log, which is a log with a base of 10. So starting in the upper left corner, the common log is a logarithm with a base of 10. You'll never actually see the base of 10 written. So if you see like log x or log of anything without a base written there, it's a common log, and you would just need to know that it means the same thing as a log with a base of 10. So anytime you don't see like the base of 10 in there, if you wanted to, you could even kind of like write it in on your scratch work, but that's something that you would want to be able to recognize on your own, is like if I don't see a base, the base is 10. Okay, so example 1, evaluate the following logs without a calculator. So a is log of 100, and there's no base written there, so that would mean that it's a base 10. And when we're evaluating logs ask us what exponent takes us from the small number to the big number. So in this case, like what exponent would take us from 10 to 100, or like 10 to what power, well, there's the answer, but 10 to what power equals 100? So the exponent that takes us from 10 to 100 is 2, so our answer would be 2. So whenever we're solving logs, our answer is an exponent, basically, the exponent that takes us from the small number to the big number. And then for b, log of 1,000, same thing, we don't see the base written there, so it would be a base of 10. So this problem is asking us 10 to what power equals 1,000, and you have to raise 10 to the third power to equal 1,000, so log of 1,000 would be 3. And again, that's because if you were to take 10 and raise it to the third power, that would equal 1,000. So our answer is that exponent. And then for c, log of 10,000, so same thing, no base, so if there's no base, it's a log of 10. This is asking like 10 to what power equals 10,000, and you have to raise 10 to the fourth power to equal 10,000, so this would be equal to 4. And then if you want to write off the side as well, it's because 10 to the fourth power equals 10,000. So our answer is just that exponent. It's the exponent that we have to put over 10 to get to 10,000. And then maybe you haven't had a chance to look at it yet, but there is a pattern here that can help us find like common logs of like multiples of, not all multiples of 10, I guess, but like powers of 10. So if you notice, like for a, log of 100, 100 has 2 zeros and the exponent was 2. And for b, log of 1,000, 1,000 has 3 zeros and the exponent was 3. And then for c, log of 10,000, 10,000 has 4 zeros and the exponent was 4. That pattern will continue. So like log of 100,000 would be 5. Okay, moving over to example 2, evaluate the following logs with a calculator. We're going to round to 2 decimal places. So if you have a calculator, even on like your phone, there's a log button and it's a common log. So any like phone calculator, or like most, if not all, scientific calculators and most graphing calculators, if you see a log button, it's just common log only. You don't really get the option to type in your base. So when that's the case, we can solve common logs, but if you need to solve a log with a different base, you have to use like kind of a more special calculator. Okay, so example 2, a is log of 21. So I'm going to switch back and forth from the calculator to this. So log of 21. So this is just like the calculator that you get if you pop up to Google, but you can use like a phone one. I'll show you what that looks like after this. But on this one, you would just click the log button like log and then type in 21 and then equals, and that'll give you your approximation. We're just going to round. We'll round to 2 decimal places. So it'll be about 1.32. So log of 21 is approximately 1.32 if we round to 2 decimal places. And then for log of 300, I'm going to show that one on a calculator that looks more like an iPhone calculator in case that one is easier too. But log of 300, So if you're using a phone calculator, you'd have to like unlock it and turn it sideways to get the log button to pop up. This one has like the log of 10 if you look like in the third row, and then what is that, like the sixth column over, like towards the middle. I believe the one on the iPhone just says like, or any phone calculator probably just says regular log, and that's okay. It's referring to common log. So we'd have to type in the 300 first for like log of 300, and then after that it would hit the log button, and it's about 2.477, but if we're rounding to 2 decimal places, that like third 7 rounds the second one up to an 8, so about 2.48. So log of 300, about 2.48. And then the last one, log of 7.2, I'm just going to go back to the Google calculator. So log of 7.2, on this one we type in the log first and then 7.2 and just enter equals. So it's a 0.857 and so on, and if we're rounding to 2 decimal places, that 7 in the third spot is going to round the 5 up to a 6. So log of 7.2 is about 0.86. And I know these feel like just a bunch of like random numbers, but remember that these are all common logs. They're all logs with like a base of 10. And even if we can't really evaluate them in our head, we can just kind of make sure that our answers make sense in context. So if I was like saying, okay, 10 to what power equals 21, well, it would be somewhere between 1 and 2, because like 10 to the first power is 10, and 10 to the second power is 100, and 21 is between 10 and 100, so my exponent has to be between 1 and 2. If I got like something greater than 2, that should be like kind of a red flag that something went wrong with the calculator, or just like the way it was typed in. And then for B, log base 10 of 300, so it's asking like 10 to what power equals 300. Well, it's got to be between like 2 and 3, because 10 to the second power is 100, and 10 to the third power equals 1,000. And we're going to 300, which is between 100 and 1,000, so our exponent must be between 2 and 3. And it's not like necessarily like proportional, because they kind of grow at different rates as the exponent increases, but you just know it should be between 2 and 3. It should be between those whole numbers. And then for C, it's saying like 10 to what power equals 7.2, where we're going down. So like if I were to raise 10 to the first power, that would be 10. And then if I were to raise 10 to like the 0 power, anything to the 0 power is 1. So since 7.2 is between 1 and 10, my exponent must be between 0 and 1. Okay, so moving down to 5.2, and this is evaluating logs with other bases, like kind of any random base that's not 10. So example 1, evaluate the following logs without a calculator. And I know that we have a calculator technically for everything, but I would like to encourage you to evaluate as many as you can without one. Okay, so A is log base 9 of 81. So what that's asking is 9 to what power is 81. So like 9 to what power equals 81. What exponent takes you from that small number to that big number, 9 to 81. So I would have to square 9 to get to 81. So my answer would be 2. So log base 9 of 81 is 2. And then for B, log base 2 of 16 is asking 2 to what power equals 16, or if I read it over here like the other way, it would be like 2 to what power equals 16. And if you're not sure, you can kind of make like a little list, like, okay, well, 2 squared, that's 4. And then like 2 to the third power is 2 times 2 times 2, so that's 8. And then 2 to the fourth power is 4 2's being multiplied together, so that would be 16. So the exponent that takes me from 2 to 16 is 4, so this would be 4. So log base 2 of 16 would be 4. And then for C, log base 4 of 1024 is asking me what exponent takes me from 4 to 1024. So, or in other words, like 4 to what power equals 1024. 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 4 to what power 24, and that one's like, I don't know, one in my head, so I'm just gonna make a list for it. So off to the side, I'll do like, you don't have to start at 4 squared if you don't need to, but 4 squared is 16, and then like 4 to the third power is 64, and then 4 to the fourth power I think is 256, but that's where I'm not confident. So 4 to the fourth power is 256. And then if I raise 4 to the fifth power, it's 1024. So the exponent that takes me from 4 to 1024 is 5. So this would be 5. So log base 4 of 1024 is 5. And then for example 2, evaluate the following logs with the calculator round to 2 decimal places. So here's where if you are evaluating a log that doesn't have a base of 10 or a base of something called e, which we talk about in the next section, if you have something other than those two bases, you'll have to use a special calculator, which is, I'll link it here, and I'll link it like above the video as well, but it's going to be the GeoGebra calculator. So the first one is log base 3 of 50. Okay, so this is the GeoGebra calculator, and to get to the log options, you have to click the f of x button. So kind of like, I guess towards the bottom of the screen, but f of x instead of like over the 1, 2, 3. And then you'll see a like log with a base of 10, that's the common log. And then you'll see the log with a little like square next to it, like third row, third column. And that's the one that lets you put in any base that you want. So we want to do log base 3 of 50. So my base would be 3. And then inside the parentheses, I'll put a 50. And then it pops up my answer right away. So it's 3.5608 and so on. And if we're rounding to 2 decimal places, it'll just be 3.56. So log base 3 of 50 is approximately 3.56. And then one more with the GeoGebra calculator is log base 3 of 31. Sorry, I think I said log base 3 of 31, but it was definitely log base 5 of 51. So for this one, we can just clear everything out. We'll click, go back to f of x if we erased everything, and then click log of x, and it was log with a base of 5. I think I said 3 the first time. So log base 5, so I put the 5 first, and then I'll click over to go inside my parentheses, and then it was of 31, so the next number would be 31. And you can see the answer pops up right away. It's like 2.13 and so on. And we're going to round to 2 decimal places, so we'll cut it off after 2.13. So log base 5 of 31 is approximately 2.13. And then again, I just kind of like recommend making sure that your answers make sense in context. And it's just like really good practice for understanding logs better in general. So this is like saying 3 to what power equals 50? Well, 3 to the third power is 27, and 3 to the fourth power is 81. I picked those two because like 3 and 4 are the whole numbers that surround our answer. So since log base 3, so since 50 is between 27 and 81, our answer 3.56 should be between those two exponents, 3 and 4, which it is. And then for B, log base 5 of 31, we got a decimal of like 2 point something, so I'm going to compare it to like 5 squared. So 5 squared is 25, and then 5 to the third power is 125. So log base 5 of 31 is saying like 5 to what power equals 31, and since 31 is between 25 and 125, it makes sense that our answer, 2.13, was between 2 and 3. Okay, moving down to 5.3, and this is about something called a natural logarithm. So the number, starting in the upper left corner over here, so the number e, which is a number, I know it sounds weird, but the number e, it's kind of like pi, where it's like a irrational number that goes on forever, but it's about 2.178. and it can be used to calculate things like compound interest or like the decay of a radioactive substance. So there is a special log that has a base of e, and it's called a natural log. So a log with a base of e is called a natural log, and it's not even written with like log. If you had a log with a base of e, it's written as ln of x. So when you see L, and this is like an L, not an I or a 1 or anything like that, a natural log, though, is written as ln instead of like log with a base of e. So it'd be ln of x. And the nice thing about natural logs, even though they're written kind of weird, is that there's also a natural log button on like a general calculator. So it's something that you could use like a phone or a scientific calculator for, as opposed to like the GeoGebra calculator, which is kind of fancy. Okay, so example 1, evaluate the following logs using a calculator. So A is ln of, or natural log of 3.9. I'm going to use the just Google calculator first. So natural log of 0.39. So on the Google calculator, the natural log button is that little ln. It's in the second row, and it's the third button from the left. So ln, and then it was a 0.39, I think. So natural log of 0.39 is like negative 0.94-ish if we round to 2 decimal places, so about negative 0.94. So natural log of 0.39 is about negative 0.94, which seems kind of weird to get a negative, but you have to remember that logs just solve for an exponent, and it's okay to have a negative exponent. It's how you go from like a base to its reciprocal, and especially since we're having a natural log, which is a base of about 2.72 if we round to 3 decimal places, we're going from that to like a number that's between 0 and 1, so think of it as like turning from like a integer into its reciprocal, like a fraction, but our like fraction, air quotes, is 0.39. It's just written in decimal form. So it's totally okay to get a negative as an outcome for a log. And then the last one is the natural log of 100. This one I'll use kind of like more like the phone style calculator for. So for natural log of 100, it's similar to when we did like the common log before. We'd want to type in the 100 first, and then you'll see the ln button. It's like in the third row of the calculator. So click ln, and then it'll pop up your answer. So 4.605 and so on. If we want to round to 2 decimal places, we have to look at the third number after the decimal, which is a 5. And since that number is 5 or more, we have to round the second number, the 0, up to a 1. So it'll be about 4.61. So about 4.61. So with logs, like yes, some are with and some are without a calculator. The goal is to always solve as many as you can without a calculator, but you can really only do that if your outcome is like integer exponents for the most part. We will get into like kind of rational exponents and stuff like that, but if they are like irrational answers, so meaning like a decimal that goes on forever, you would have to use a calculator to evaluate it.